This video will focus on angles, obtuse angles, acute angles, right angles, and how they fit together. It will be more conceptual. We will be doing the work down here, and I'll be marking the questions up here. So first, can the difference of two obtuse angles be obtuse? As you know, the definition of an obtuse angle is it is between 90 and 180, not including 90, not including 180. Notice I did not say greater than or equal to, less than or equal to here, just greater than, less than. But let's say we go to those endpoints, the largest angle we could possibly have minus the smallest angle we could possibly have at the endpoint of obtuse. That would be 90 degrees. So no, absolutely not. Even if we take the largest and the smallest, we still get a 90-degree angle. So no, the difference of two obtuse angles cannot be obtuse. Next, does the difference of two acute angles have to be acute? Well, an acute angle is greater than 0 and less than 90. So let's also draw this. Let's say, so an acute angle is less than 90. So let's say I have the difference of two acute angles has to be acute. It cannot be greater than 90. The one exception to this would be, let's say I have a 30-degree angle and a 30-degree angle. Those subtract to 0 degrees. So that is not an angle at all. But in general, yes, the difference of two acute angles has to be acute. Next question, if one angle of a triangle is a right angle, can one of the other angles be obtuse? So again, we're going to draw ourselves a picture. You will find most things in geometry are much easier if you draw them out and you can see them visually. That is a right angle. We're going to call that angle A and angle B. So as you know, 90 plus A plus B equals 180 because there are 180 degrees in a triangle. Therefore, A plus B equals 90. Now, a little bit of mental gymnastics here, but it's not terrible. If A plus B is 90 and A and B have to be greater than 0 because otherwise you don't have an angle, then either A or B must be less than 90. A must be less than 90. B also must be less than 90. So the answer to this question is no. If you have a right triangle, one of the other angles cannot be obtuse. So these next two questions we're going to do individually, but they're a bit of a tandem question. Can two acute angles be supplementary? So again, let's draw ourselves a picture. Supplementary angles add up to 180. Let's say we do that. Acute, obtuse. Okay. Fair enough. Let's raise this up. Acute, obtuse. Let's raise the angle up a little bit more. Acute, obtuse. Until we get to here, where it is straight up. And then in that case, that's a 90 and that's a 90. So as you can see, once we get past here, if we go that way, now we have acute here and obtuse there. So no, two acute angles cannot be supplementary. Now we go to here. If two angles are supplementary and congruent, what must be true? Well, let's draw ourselves a picture. Supplementary and congruent right here. Now let's do some algebra. If one angle, say, is W and the other angle is W and they add up to 180, well, 2W equals 180, W equals 90. So these both must be right angles. So the question is, if two angles are supplementary and congruent, what must be true? They must both be right angles. And that is the answer to this question here. Now, this next question is a little bit longer. So to set it off from the shorter questions, I wrote it in red, and we'll do the solution in red. If A, B, and C are collinear, AB is 25, BC is 15, and AC is 10. Which point must be between the other two? Well, notice here the longest one is 25. BC is 15, AC is 10. 10 plus 15 is 25. So here we go. So for that to be true, if this whole thing is 25, so that's A, and then that's B, well then AC is 10, BC is 15. We're going to try and do it as to scale as I can get it. So C would be about right there. And then AC is 10 and BC is 15. Adding up to 25. And that's how you do it. Again, in geometry, even if you're doing conceptual questions, it really, really helps to draw it out so you can see it. Anything visual in geometry is much easier than doing it in your head.